Okay, let's look at three different kinds of problems, just to kind of summarize what we've learned from rationals. So we want to really pay attention closely to the directions. The directions actually give you a hint as to what's going on and what your goal is, because it can be really confusing. Like if you look at these three problems, they all kind of look the same, and without really looking at them closely, you might not be sure how to proceed. So if we look at the first one, the directions say simplify. So we know that this is what kind of equation? It's an expression. It's not an equation, right? Because an equation has to have an equal sign, and the equation will have the word solve. So when I want to solve, I want to get x by itself. This is just telling me to simplify. I'm adding three, what kind of things? Rational expressions, aka fractions. What do I need to have when I add fractions? Common denominator, I heard you say. Yes, you need a common denominator. Okay, so what's the LCD, the lowest common denominator for all three? 3x. So everybody has to have 3x. Now, can I clear fractions when I'm simplifying? And the answer is no. Why can't I clear fractions? When we were solving, I could clear them. Why can't I clear them with an expression? It's because I can't do something to both sides, right? I can't eliminate the fractions, because with an equation, I can do the same thing to both sides and get rid of the fractions. But here I can't, because there's no both sides. Okay, so this one already has 3x, so I can leave that as 5 over 3x. And what do I need to do to this one so that it can get that common denominator of 3x? Yeah, 3 over 3. So I get 9 over 3x. And then what about 1? Do I have to have it have a common denominator? And what's that going to be? I can multiply it, yes, by 3x over 3x. So 3x over 3x, yep, that's equal to 1. Should I go ahead and reduce these? Like, I see some fractions that can reduce. Would I want to reduce? And you say no reducing now. Why not? We just got the common denominators so that we could do what? Yes, and what are we adding? Numerators. And one thing is about how you're showing your work, go ahead and write an equal sign on your first step when it's simplifying, and then you're going to carry your work down vertically. That way it's going to be really clear what you do step by step. So we're going to add the numerators, and if we add the numerators here, we get 3x plus 5 plus 9 is... Oops, I was like 11. Oh, wait, no, 14. Is it 14? Did I get that right? And is it okay that I changed that order? I just put it in standard form. I put the 3x first because that's typically how you see it. Now, can you just cancel those 3 x's? I thought I would want to be able to divide. Could I? No. And that's because of this plus 14 in the middle, okay? So we can't divide this. We can look at the numerator and see if anything can factor. Is there a greatest common factor between 3 and 14? Why not? 3 doesn't go into 14, right? And 3 is prime, so nothing goes into either one. Now, if we look at this one that says solve, I want to be able to get x by itself. This is the equation where I could clear fractions, because with an equation you can do whatever you want so long as you do the same thing to both sides. So here we could clear the fractions by multiplying both sides by what? Yeah, 3x. So each term gets multiplied by 3x. The 3x's cancel, leaving 5. The x's cancel, leaving 3 times 3, which is 9. And then the 3x doesn't have anything to cancel with here, so we have 3x on this side. And what would you do now to solve? Yeah, so we combine our like terms. We have 14 equals 3x, and to solve, you could divide both sides by 3, leaving x equals 14 thirds. Now I put the x on the other side and the number on the other side. Does that matter? 14/3 equals x, same thing. We can't reduce that fraction. If we're solving, we put the answer in set notation. Notice here when I simplified, I did not use the set notation. And I could check this, right? So to check it, I would plug it back in. And I would get, 5/3 times 14/3 plus 3/14/3 equals 1. I'm not sure if it's correct yet, so I put the question mark there. Here, this just becomes a complex fraction. The 3's cancel, leaving 5/14 plus, if I multiply by the reciprocal, I get 3 over, because I'm dividing by a fraction, 3/14. And is that equal to 1? Well, 5/14 plus 9/14 is equal to 1. 14/14 equals 1, which is true. Oops, I went off the page. I was writing. Okay, so that's the difference between solve and simplify. Now here, what are we going to do with this one? It says to simplify. And this one we can clear fractions because we're going to multiply the numerator and the denominator by the same thing. So I'm actually technically not changing the value since I'm still multiplying by 1. What's the LCD? 3x. Okay, here I have to distribute. So I'm actually multiplying this one by 3x and the 1 by the 3x. These 3x's cancel, leaving 5 in the numerator. These has nothing to cancel with, so it's plus 3x. Here in the denominator, I'm multiplying. I'm going to just move it closer. Okay, it got multiplied. I'm multiplying by 3x over 1 because I'm doing the same thing in the numerator denominator. What happens to the x's? The x's are going to cancel, and I have 3 times 3, which is 9. And then from here, you wouldn't reduce here, okay, unless you wrote it as 5/9 plus 3x over 9. But notice that we needed a common denominator to add. There's nothing that we can factor out of the numerator, so we wouldn't just be able to cancel here because of the addition sign that's in between. But this would be equivalent if you did want to reduce that to 1/3. You could, but you would need it to have a 9 if you wanted to add it back together. So I would be fine just like this. That would be enough. Okay, and we notice I don't use the set notation here because I didn't solve anything. All I did is I took one complex fraction and simplified it. Okay, so it's kind of like 3 different styles of rational problems.